Picture this. You wake up tomorrow morning and discover something extraordinary. Your house is slowly drifting away from all the others in your neighborhood. But it's not just your house. Your entire neighborhood is moving away from the next one over. Cities are gradually separating from each other, and continents are drifting apart at an unprecedented scale. As incredible as this sounds, this is precisely what's happening right now on a cosmic scale. The entire universe is expanding. This isn't science fiction or a thought experiment. It's one of the most profound realities of our cosmos. Every second of every day, the fabric of space itself is stretching, causing galaxies to drift away from one another in a cosmic dance that has been ongoing for billions of years. This remarkable phenomenon is happening everywhere we look, from the nearest galaxies to the farthest reaches of the observable universe. Greetings, fellow cosmic explorers. Today, we're about to embark on an incredible journey into one of science's most revolutionary discoveries, the expanding universe. This isn't just another scientific concept, it's a fundamental revelation that completely transformed our understanding of reality itself. When this discovery was first made, it shattered centuries of established beliefs about a static, unchanging cosmos and opened up new questions about our universe's past, present, and future. What we're about to explore will challenge your imagination and perhaps even change the way you think about your place in the cosmos. The expansion of the universe isn't just a distant phenomenon happening somewhere out there in space. It's a fundamental aspect of reality that affects everything around us, including the very space between atoms in your body. Though we can't feel it in our daily lives due to the overwhelming strength of local gravitational forces, this cosmic expansion is constantly at work on the grandest of scales. For those of you who have always been fascinated by the cosmos and its deepest mysteries, you've come to the right place. We're about to delve into a story that combines groundbreaking observations, brilliant scientific insights, and some of the most profound questions humanity has ever asked. This journey will take us from the early days of modern astronomy to the cutting edge of contemporary cosmology, revealing how our understanding of the universe's expansion continues to evolve with each new discovery. The expansion of the universe stands as one of the pillars of modern cosmology, yet it remains surrounded by intriguing mysteries that continue to challenge our brightest minds. As we explore this phenomenon together, we'll uncover not just what we know, but also what remains unknown, the questions that keep astronomers awake at night and drive the future of cosmic exploration. So, buckle up for an extraordinary adventure through space and time as we explore the remarkable story of our expanding universe. Whether you're a seasoned science enthusiast or just beginning to explore the wonders of the cosmos, this journey promises to expand your horizons just as surely as the universe expands itself. Let's travel back to 1920, to a pivotal moment in scientific history that occurred atop Mount Wilson Observatory in California. On a crisp, clear night, astronomer Edwin Hubble sat at the eyepiece of the world's most powerful telescope at the time, the 100-inch Hooker telescope. What he would observe during his meticulous studies of the night sky would fundamentally change our understanding of the cosmos forever. At that time, the prevailing belief among scientists, including Albert Einstein, was that the universe was static and unchanging. Even Einstein had added a cosmological constant to his equations of general relativity to prevent the universe from collapsing under its own gravity, a mathematical term he would later call his biggest blunder. As Hubble studied distant galaxies through the telescope's eyepiece, he began to notice something peculiar. When analyzing the light from these distant cosmic objects, he discovered a consistent pattern that would prove revolutionary. The light from virtually all distant galaxies showed a shift toward the red end of the spectrum, a phenomenon we now call redshift. The further away the galaxy, the more pronounced this redshift appeared to be. To understand this redshift phenomenon, consider the familiar sound of an ambulance siren as it passes by. As the ambulance approaches, the siren's pitch sounds higher than normal, and as it drives away, the pitch drops lower. This is known as the Doppler effect. The same principle applies to light waves from objects moving away from us in space. Just as the ambulance's sound waves are stretched out as it moves away, making the pitch lower, light waves from receding galaxies are stretched toward the red end of the spectrum. This observation was nothing short of revolutionary. What Hubble had discovered was evidence that the universe was not static at all. It was in constant motion, with galaxies moving away from each other. Even more remarkably, he found that the farther away a galaxy was, the faster it appeared to be moving away from us. This relationship would later become known as Hubble's law. The implications of this discovery were staggering. If galaxies were moving away from each other, then rewinding this motion would mean that everything in the universe must have been closer together in the past. Following this logic to its ultimate conclusion led to an even more profound realization. At some point in the distant past, all matter in the universe must have been concentrated in an incredibly dense state, what we now know as the beginning of the Big Bang. Hubble's observations didn't just change our view of the cosmos, they fundamentally altered our understanding of the universe's history and evolution. The static, eternal universe of previous centuries was replaced by a dynamic, evolving cosmos that had a beginning and was continuously expanding. This discovery marked the birth of modern cosmology and opened up entirely new fields of scientific inquiry. The data Hubble collected was so precise and compelling that it couldn't be ignored. Even Einstein, upon learning of Hubble's findings, traveled to Mount Wilson to see the evidence for himself. After reviewing Hubble's work, Einstein acknowledged that his cosmological constant, which he had added to his equations to maintain a static universe, was unnecessary. The universe was indeed expanding, just as Hubble's observations suggested. This monumental discovery set the stage for decades of further research and raised new questions that continue to puzzle scientists today. How fast exactly is the universe expanding? What drives this expansion? Will it continue forever? These questions would lead to even more surprising discoveries about dark energy and the accelerating expansion of the universe. But it all began with those careful observations made by Edwin Hubble on Mount Wilson, forever changing our perspective on the cosmos. The Hubble-Lemaitre constant stands as one of the most critical numbers in all of cosmology. It's quite literally the measure of our universe's expansion rate. Initially called the Hubble constant, it was later renamed to also honor Georges Lemaitre, who had theoretically predicted the expansion of the universe before Hubble's observations confirmed it. This constant tells us how quickly galaxies are moving away from each other, and holds the key to understanding both the age and fate of our universe. To truly grasp what this constant measures, picture a loaf of raisin bread rising in the oven. As the dough expands, each raisin moves away from every other raisin. The raisins aren't moving through the dough, rather the dough itself is expanding, carrying the raisins along with it. Now imagine that the farther apart two raisins are, the faster they move away from each other. This is exactly what happens in our universe, where galaxies take the place of raisins, and space itself plays the role of the expanding dough. The Hubble-Lemaitre constant quantifies this expansion rate, typically expressed in kilometers per second per megaparsec. In simpler terms, it tells us how fast two galaxies are moving apart based on their distance from each other. If you know this constant and measure how far away a galaxy is, you can calculate how quickly it's moving away from us, or vice versa. However, here's where things get truly fascinating and perplexing. Modern astronomers have encountered what's now known as the Hubble tension. When they measure the expansion rate using different methods, they get significantly different results. It's as if we're measuring the same room with different rulers and getting noticeably different lengths each time. One method involves studying the cosmic microwave background, the afterglow of the Big Bang, which suggests one value for the constant. Another method uses observations of specific types of stars called Cepheid variables and type Ia supernovae in distant galaxies, which consistently indicates a different, higher value. These discrepancies aren't small. They're significant enough to suggest that something fundamental about our understanding of the universe might be incomplete or incorrect. This tension between different measurements has become one of modern cosmology's most pressing puzzles. Are we missing something about how the universe works? Could there be unknown physics at play? Is it possible that the expansion rate has changed over time in ways we don't yet understand? These questions force us to confront the humbling reality that despite all our technological advances and scientific progress, the universe still holds profound mysteries. The implications of resolving this discrepancy could be revolutionary. If the higher value is correct, it might suggest the presence of new types of particles or forces we haven't yet discovered. If the lower value is right, it could mean we need to revise our understanding of dark energy, the mysterious force that appears to be accelerating the universe's expansion. This brings us to perhaps the most intriguing question of all. Will the universe continue expanding forever? Based on current observations, the answer appears to be yes. And not only that, the expansion seems to be accelerating. This acceleration, attributed to dark energy, suggests that the universe might expand eternally, growing ever larger and colder in what astronomers call the Big Freeze or heat death scenario. However, the Hubble tension reminds us that our understanding is still evolving. The final answer might be more complex and fascinating than we currently imagine. The way this constant behaves over time could hold clues to the ultimate fate of our universe. Whether it will expand forever, eventually slow down, or perhaps even reverse course in a big crunch. As we continue to refine our measurements and develop new ways to study cosmic expansion, each discovery brings us closer to understanding not just how our universe grows, but potentially why it grows the way it does. The Hubble-Lemaitre constant and the mystery surrounding its precise value stands as a humbling reminder that even some of the most fundamental aspects of our cosmos still hold secrets waiting to be uncovered. When we peer into the cosmic abyss, trying to understand the universe's expansion, we encounter some of the most profound mysteries in modern science. Let's explore these enigmatic puzzles that continue to challenge our brightest minds and push the boundaries of human knowledge. Perhaps the most perplexing discovery of modern cosmology came in 1998, when astronomers found that the universe isn't just expanding, it's accelerating in its expansion. This revelation earned the 2011 Nobel Prize in Physics, but it also presented scientists with a cosmic-scale puzzle. What force could be powerful enough to overcome gravity's pull and drive galaxies apart at ever-increasing speeds? Enter dark energy, a mysterious force that appears to permeate all of space. Unlike any other known form of energy or matter, dark energy seems to become more dominant as the universe expands. It makes up approximately 68% of the universe's total energy content, yet we can't directly observe or measure it. Think of it as an invisible cosmic spring that stretches between galaxies, becoming more powerful as the distance increases. Scientists have proposed various theories about dark energy's nature. Could it be Einstein's cosmological constant, representing the energy of empty space itself? Might it be a new field, dubbed quintessence, that varies over time? Or perhaps our understanding of gravity itself needs revision? These questions remain at the frontier of physical science. The Hubble tension represents one of the most significant challenges to our understanding of cosmic expansion. Different methods of measuring the universe's expansion rate, the Hubble constant, give us conflicting results, and this discrepancy has only grown more significant with increasingly precise measurements. When astronomers measure the expansion rate using the cosmic microwave background, the afterglow of the Big Bang, they get one value. But when they measure it using closer objects like supernovae and variable stars, they consistently get a higher value. This difference isn't just a small experimental error, it's a statistically significant gap that suggests either our measurements are systematically flawed, which seems unlikely given the various methods used, or our understanding of cosmic evolution is incomplete. This paradox could be pointing to new physics we haven't yet discovered. Perhaps there's an unknown particle affecting cosmic expansion, or maybe dark energy has properties we haven't yet recognized. Some scientists even suggest that our universe might have experienced a sudden change in its expansion rate, creating this apparent contradiction in our measurements. As we project the universe's expansion into the distant future, several possible scenarios emerge, each more mind-bending than the last. The Big Freeze. Currently considered the most likely scenario, the Big Freeze envisions a universe that continues expanding forever, driven by dark energy. Over countless billions of years, galaxies would grow so far apart that they'd become invisible to each other. Stars would eventually burn out, and black holes would evaporate through Hawking radiation. The universe would become an impossibly vast, cold, dark space, a cosmic graveyard of scattered fundamental particles. The Big Rip. In this more dramatic scenario, dark energy becomes so powerful that it eventually overcomes all other forces, even the strong nuclear force holding atoms together. The universe would literally tear itself apart, first ripping galaxies to pieces, then solar systems, planets, and finally atoms themselves. Everything would be reduced to its most fundamental components, scattered across an infinite void. The Big Crunch. This scenario, less favored by current observations but still possible, suggests that the universe's expansion might eventually slow and reverse. Gravity would finally win its battle against dark energy, pulling everything back together in a cosmic finale that mirrors the Big Bang in reverse. All matter and energy would collapse into an infinitely dense point, perhaps setting the stage for another Big Bang and a new universe. These mysteries remind us that despite our remarkable progress in understanding the cosmos, we're still standing at the shores of a vast ocean of unknown physics. The questions raised by cosmic expansion challenge our most fundamental theories and push us to explore new realms of physics and mathematics. They remind us that science is not just about finding answers, but about discovering better questions to ask. As we continue to observe the cosmos with increasingly sophisticated instruments and analyze our findings with more powerful computers, we edge closer to understanding these mysteries. Yet each answer seems to bring new questions, making the study of cosmic expansion one of the most dynamic and exciting fields in modern science. The expansion of the universe may seem like a distant, abstract concept far removed from our daily lives, but its implications profoundly affect our understanding of existence and our place in the cosmic story. Let's explore how this grand cosmic dance shapes our perspective of reality and our role within it. The expansion of the universe fundamentally challenges our intuitive understanding of reality. From our everyday experience, we expect things to stay relatively constant or to change in predictable ways. Yet here we are, living in a universe that's not just moving, but actively expanding in all directions. This revelation forces us to confront the dynamic nature of existence itself. The space between galaxies is stretching, the cosmos is evolving, and we are part of this grand cosmic evolution. Consider what this means for our concept of stability and permanence. The night sky we see today is not the same one our ancestors saw, nor will it be the same one our descendants will observe thousands of years from now. As galaxies drift further apart, future civilizations will see fewer stars and galaxies in their night sky. In a very real sense, we're living in a unique moment in cosmic history, able to observe distant galaxies that will eventually fade from view as the universe continues its relentless expansion. This understanding also transforms our perspective on cosmic isolation. As the universe expands, we become increasingly isolated in our cosmic neighborhood. The galaxies we can see today will eventually move beyond our observable horizon, leaving our local group of galaxies as an island in an ever-darkening sea of space. This realization adds a poignant dimension to our current efforts to study the cosmos. We're living in a privileged time when the universe's larger structure is still observable and studyable. The expansion of the universe also provides us with a profound sense of our temporal place in cosmic history. By understanding how the universe expands, we can trace its history back to its origins and project its future evolution. This gives us a cosmic context for our existence. We are living roughly 13.8 billion years after the Big Bang, in what might be considered the universe's stellar age, when stars and galaxies are abundant and active. This knowledge helps us appreciate our moment in cosmic time. Perhaps most significantly, the expanding universe teaches us about the nature of scientific discovery and human understanding. It reminds us that our most basic assumptions can be wrong, that reality can be far more strange and wonderful than we imagine. When Edwin Hubble discovered the universe's expansion, it completely overthrew the prevailing view of a static universe. This teaches us the value of remaining open to new ideas and being willing to revise our understanding when evidence demands it. The beauty of living in such a dynamic and mysterious universe lies in its constant capacity to surprise and inspire us. Every new discovery about cosmic expansion reveals more layers of complexity and wonder. The fact that we, collections of atoms and molecules, can comprehend and study the expansion of the entire universe is nothing short of remarkable. It speaks to the profound connection between our consciousness and the cosmos we inhabit. Moreover, the mysteries surrounding cosmic expansion, dark energy, the Hubble tension, and the universe's ultimate fate remind us that the universe still holds many secrets. This continuing mystery adds a sense of adventure to human existence. We are not just passive observers, but active explorers of cosmic reality, using our intelligence and creativity to unlock the universe's deepest secrets. The expanding universe also gives us a unique perspective on our collective human endeavor. The challenges of understanding cosmic expansion require international collaboration, shared knowledge, and collective human effort. In this way, the study of cosmic expansion becomes a unifying human adventure, transcending national and cultural boundaries. Finally, understanding cosmic expansion instills in us a sense of cosmic humility while simultaneously celebrating human achievement. We are tiny beings on a small planet, yet we've managed to discover and measure the expansion of the entire observable universe. This paradox, our physical insignificance coupled with our intellectual reach, captures something profound about the human condition and our special place in the cosmos. Living in an expanding universe reminds us daily that we are part of something far greater than ourselves, a vast, dynamic, and evolving cosmos that continues to unfold in ways we are only beginning to understand. This knowledge doesn't diminish our significance. Rather, it enriches our appreciation of existence and our role as conscious observers and explorers of this magnificent cosmic dance. As we conclude our journey through the fascinating realm of cosmic expansion, we find ourselves standing at a unique vantage point in human history. Our exploration of the expanding universe reveals not just the current state of our cosmological understanding, but also illuminates the very nature of scientific discovery itself. The story of cosmic expansion is far from complete. With each new observation, With every precise measurement, and with all our technological advances, we continue to uncover new mysteries that challenge our understanding. The ongoing debate about the true value of the Hubble-Lemaitre constant, the enigmatic nature of dark energy, and the ultimate fate of our universe all remind us that we stand at the frontier of human knowledge, with vast territories yet to explore. Perhaps the most beautiful aspect of this scientific journey is how each discovery leads to new questions. When Edwin Hubble first observed the expanding universe, he couldn't have imagined the questions his discovery would raise about dark energy or cosmic acceleration. When scientists first measured the expansion rate, they couldn't have anticipated the modern puzzle of the Hubble tension. This is the true essence of science, not just finding answers, but uncovering better, deeper questions to ask. Our understanding of cosmic expansion has transformed our perspective of the universe from a static, eternal backdrop to a dynamic, evolving stage where space itself participates in the cosmic dance. This shift in perspective represents one of humanity's greatest intellectual achievements, demonstrating our ability to transcend our limited earthbound experience and grasp the true nature of our cosmic home. Yet, we must remain humble before the magnitude of what we still don't know. The mysteries of dark energy, the contradictions in our measurements, and the uncertainty about our universe's ultimate fate all serve as reminders that we are still at the beginning of our journey to understand the cosmos. These unknowns aren't failures of science. They are invitations to deeper exploration, beacons guiding us toward new discoveries. The expanding universe also teaches us something profound about the scientific method itself. It shows us how observation, theory, and technology work together to advance our understanding. It demonstrates how science can overturn even our most basic assumptions when evidence demands it, and how the pursuit of precision can reveal entirely new mysteries. As we look to the future, the study of cosmic expansion promises even more exciting discoveries. New telescopes, more precise measurements, and innovative theoretical approaches are being developed that may help resolve current mysteries and undoubtedly reveal new ones. The next generation of scientists will have tools and opportunities we can only dream of today. This ongoing journey of discovery invites all of us to be part of humanity's greatest adventure, understanding our place in the cosmos. Whether you're a professional astronomer, a student of science, or simply someone who looks up at the night sky with wonder, you're part of this grand endeavor to comprehend the expanding universe. For those who wish to continue this fascinating journey of cosmic exploration, there are always new horizons to discover. Next week, we'll delve into another remarkable aspect of our universe: gravitational waves, the ripples in space-time that carry echoes of cosmic events across the vastness of space. These waves, first predicted by Einstein and finally detected in 2015, open up an entirely new way of observing our universe, promising to reveal secrets that light alone could never show us. Join us as we continue to explore these cosmic frontiers, unraveling the mysteries of our universe one discovery at a time. Remember, every question we answer leads us to new and more fascinating questions to explore. This is the endless adventure of science, and you're invited to be part of it. The universe is expanding, and with it, our understanding continues to grow. In the end, the expanding universe reminds us that we live in a cosmos more magnificent and mysterious than we ever imagined. It challenges us to push the boundaries of our knowledge while remaining humble before the vast unknown. As we continue our exploration, we carry forward the torch of human curiosity, illuminating the darkness one discovery at a time, always aware that the greatest discoveries may still lie ahead.